I'm going to talk to you a little bit about the way that Clover processes a graph, if you like, the philosophy behind Clover. Um, what we're looking at here is a graph with a number of components, and basically all data is thought of in terms of rows. So in this component here is reading in orders from a CSV file, order items, customers, all from a CSV file. And it's going to be reading in one row at a time. Now, one of the other very clever things about Clover is that it's multi-threaded. So as these rows are read in, they are immediately passed on to the next component. So what it's not doing is reading in all the orders and then all the order items, all the customers, if you like. So it's doing it row at a time, all in parallel. So as an order is read from the order CSV file, it's immediately, that first order, sent down this edge into this component here, which is actually doing a join on these two record sources. And Clover basically works out whether it's got all the data it needs at any particular time to process it. So if this component doesn't think it's got enough data to process, it'll wait. But as soon as it's got all of the necessary data, it's immediately going to start working on what it considers an output row in this case, and it will send it down this edge here. Same while all that's going on, the customer file is being processed, and it's being sent down this edge, and it's being joined again, and so on. So basically, Clover will work out whether it's got what it needs, but everything will be done in parallel, which means you can have effectively different processes running on different threads on different processor cores. So the other thing which is important to think of is when data is processed. So here, for instance, data is read in from the file, and then it gets passed to this edge. So it's get passed to the output port down the edge. Now, what Clover will do is it will assign metadata. In fact, the user has to assign metadata to any particular edge. And that tells Clover what data format this pipe has. So when the order data is read in, it gets shoved into that pipe, which becomes the input port for this. Now, if the data format doesn't match the metadata format, so if the orders aren't really the right things to be shoving down this pipe into that metadata structure, Clover will complain. So metadata is the way you define the movement of data between any two components. And here on this graph, we're actually able to, with debug mode on, we can enable a debug flag for any of these edges. We can actually see the flow of data, how many rows are being moved along each of these pipes or edges. Now, I talked about Clover being multi-threaded, so all of these components effectively running in parallel, or in separate threads at any rate. Now, there are cases where that is problematic, because if we had several things going on in, well, let me go over here. We've got things going on in sequence, or we want them to execute in sequence. That could cause a problem. So let's say, for instance, we wanted this whole chain of events here to execute to completion before we run this HTTP GET call, and that to complete before we run the HTTP POST. Then what we can do is we can set phases, and we can set those anywhere we like in the middle of a graph. So if I were to, for instance, say, well, this one here should become phase 1. You can see in the top left corner we've got the phase numbers. These are phase zeros. Let's set this to phase 1. So I double click on it. In fact, I can do it that way, I think, but the way I'm familiar with is to right click on it and say set phase. And here I'm going to say phase 1, and this one will make phase 2. So now that will execute, all of this will go first, and only once it's all been processed will we start with this, and once that's been fully processed will it go on to the post. So I hope that gives you at least an introduction to what I sort of think of as the Clover philosophy.